folks, this is video number 25 in the playlist which is on motion design application 3D experience. Uh, Actually, I want to discuss the problem that was already done in video 23, and it involved a cylinder which was rolling inside of a cylinder. And this is going to be shown to you with minimum work. How do you arrange it so that this cylinder, inside cylinder, is dropped at different heights? Okay, but that problem is solved in video 23 using the roll curve joint. What I want to show you, if you use that roll curve joint, it's going to run into some unexpected behavior, and you basically have to delete it and do it directly as a curved tangency joint, as you'll see. So the things that we're going to be discussing is basically roll curve joint, curved tangency joint, initial condition, and the unexpected behavior in the problem if you did it with the roll curve joint as it was in video 23. So let me remind you what the problem was. We have a fixed outer cylinder and we have a cylinder inside of it, and this is rolling. This inside cylinder is rolling on that surface, and we want to do it so that this cylinder is initially released at different heights or different positions along this outer cylinder. Okay. All right. Okay. So let's go ahead and start with the assembly design. First, I'll do the outer cylinder. So right click, insert 3D part. These are all done in tutorial 23 or video 23, but I'll do it again. So this is outer. This is the outer cylinder. Outer. And I'm going to make it yellow. I use the same dimensions that I did before. The radius, big radius of the radius of the outer cylinder is 1. So we go to the part design. On that vertical plane, I'll sketch. To make my job easier, here's how I'm going to do this. I'll use an arc centered at the origin. Radius. Okay, let me give this thing radius 1 meter. Really, these are not critical, except that I want to repeat same geometry that I had in tutorial 23. And then I'll do another one. The actual radius here doesn't matter. The inside one does, 1 meter. So close it. Close it. Let's see if we can actually independently show. Oh, this can be fixed. This has to be fixed. So this control that. Control this. Make it, how about 0 is good. So now you can see that if you grab it, it moves in unison. Okay, very good. Exit. I'm going to pat this thing by, it doesn't matter, make it point 0.2. There we are. Now we're going to insert our inner cylinder. So insert 3D part. I'm going to call this thing inner. The one that's rolling basically. All right, let's go make it. So on that vertical plane, I will sketch. On purpose, I'm going to draw it so that it's at the very bottom of this thing. Or actually, no, I guess not. No, that's okay. Don't worry about it. So I'm going to draw it like this, any somewhere here. This is exactly how I did it in that tutorial. Let me give this thing a radius 0.1. And then the distance from here, let me draw a line here, a construction line in a minute. The distance from here to here. Okay, and that I'm going to make it 0.9 so that it makes the two touch each other and tangent. Good. Now, I want to change this to construction because we want to pad this thing. Exit. Pad this thing by, I don't know, maybe point 0.1. Okay, good. Now, let's go all the way out, assembly, and then we're going to fix this track or outer cylinder. So under assembly, under engineering, under engineering connection fix, we're going to fix the outer cylinder. And now I'm going to make a roll curve joint between this edge, that circular edge in the back, and this circular edge in the back. Okay, so how do you do roll curve joint? You go to, you won't find it in here, you go to engineering connection, wait for this thing to show up, check for roll curve, you can see that, it needs two curves. I just select this outer curve, outer circle, and this outer circle from the other side. See that? That is this, and that is it. Now, in tutorial 23, I may have done this thing so that it's the two front ones that are touching each other, and I've done it like that. Okay, but here I'll do it differently. What I'm saying is that in tutorial 23, video 23, this was this circle and that edge, when they were touching, they have to be touching. If it's a roll curve joint, they have to be touching. I made that thing roll curve joint. Now, I also showed you in the same tutorial that if you solve this problem, it may work, except that this will roll, but it's wobble back and forth. To avoid that, what I'm going to do, I will create another connection called planar. That means I'll use this template. These two faces remain kind of in the same plane. It's a new, create new, and then we say OK. So now when this thing rolls later on, it will not wobble back and forth. All right, now, yeah, so these are my the fixed part. These are roll curve planar, and we're good. So now we're going to go to motion design. This is exactly what I did in tutorial 23, and it will work. Then I will show you that if you try to change the position of that ball, of that cylinder, it's going to run into problem. You'll see that. You say, okay? All right. Now, everything is ready to go. There's nothing else to do. Gravity is acting down. It's over, I don't know, default 5 seconds, no problem. So let's go ahead and run it actually. You can actually do a preview here. See this preview? You click on it. We'll do a preview. We roll back and forth. Okay, good. Exit. And let me go run it. So simulation. Run it. Wait until it finishes. It finished. These are all repetition from 23. And the rest of it is going to show you what the issue is in a minute. Now, yeah, so select this result, go to the animation. Okay, no problem. Now, suppose I want to drop this thing from different heights. Okay, Suppose I want to drop this thing from different heights. How do I do that? Well, of course, you can go and redraw these curves at different heights, etc., etc. But if you go to mechanism, there is something called initial condition. See that? Initial condition. You click on it, and we do the initial condition for the joint because we have a joint, roll curve joint. Okay, actually, let me close this thing for a second. Show you that there is a joint here, roll curve joint, and a planar joint. Okay, so let's do it again. Initial condition for a joint. Select the roll curve joint. Don't worry about rotation. It's the position along that roll curve joint. So position. Now, one end is position 0, length equal to 0. The other end is position s equal to, or whatever length is, equal to the perimeter of this half of the circle, right? So this is s equal to 0. This is s equal to, if the radius is 1, it's going to be 3.14, s equal to 0.14, and right now it's somewhere. So right now, suppose I make it position, I don't know, maybe position maybe position 1. See that? Position 1. That means if this is s equal to 0, you go 1 unit, and that's where the initial condition is going to be. The ball is going to be positioned there. Okay? This should work, but you're going to run into a problem. We'll see. So, okay? All right. Now, if I go, first of all, if you want to look at the where it is, you go, in principle, you should say, show me the initial state solved. This should put it back where s equal to 1 is. And it says it failed, unexpected fail. As a matter of fact, say, okay, I don't want to use this thing. Let me go ahead and run it. See? Failed. And when you go to the messages, it's totally useless. Okay. The thing is that this trick, this initial position that I created, does not work when you have a roll curve. So how am I going to fix this thing? Okay, no problem. This is where the rest of the issue comes, curve tangency. What does that mean? I'm going to go and delete this roll curve, delete this joint, gone. The plane is still there, but also notice that there is these things that were created in the assembly as engineering connection. We may have to come back and delete this thing too. Well, let's not worry about it right now. So the roll curve joint is gone. That initial condition that I tried to create, where was it? Initial condition. See, because the roll curve joint is gone, obviously that's useless. So let me delete this. Otherwise, it's going to come back and say, I don't know what to do with you. Remember, I just deleted my roll curve joint. So I'm going to delete this too. Gone. Okay, now we will create this roll curve joint manually in here, in the mechanism. So let's go to mechanism. Let's go to joint. Here's a joint. And what I want is a roll curve joint, but you don't even see a roll curve joint here. Look, scroll down. There is no roll curve joint. There's point curve. There is point surface, but there is something called curve tangency. This is what that roll curve joint is. You click on it, and once again, you go and select those two curves. One is the circle. The other one is out here. And you want this thing to be rolling. See that? Rolling. You click on it. That's okay, no problem. And then say okay. All right. First of all, let's go ahead and run it. Make sure it works. So let's we can do a preview here. Yeah, See, roll curve joint work too, but now we're going to apply the initial condition that did not work for roll curve joint. So you go to mechanism, you go to initial condition for a joint, select the roll curve joint that you just created. Sorry, the curve tangency joint, select this, and now put, for example, position. How about putting, I don't know, maybe we put a 1, and then we say OK. Now, if you want to see where that thing is, you don't have to, but if you want to, you can say initial state solve. There, there. And then you can run it. You don't have to do this thing. Even if you didn't do this thing and you ran it, it will work. But it's sometimes helpful to see whether we made a mistake or not in that position. So let's go ahead and run it. Done. So select the result. Result, go to play animation and play it. Now, if you said that, okay, you know what, I actually wanted this thing to be at distance equal to 0. 0 is going to be all the way on the top. So go back to that initial condition right there, initial condition right there. Instead of 1 meter, put a 0. 0 will put you either at this end or that end. I'm pretty sure it puts it at that end. If you want to see it, whether it's at the right location or not, you can go and say initial state solve there. And then we say OK. If you want to run it, then you can go simulation on this. Okay, it's done. Select the dynamic step, result, play animation, play it right there. Okay. Now, let's say that we want this thing to be at the other end, closer to the tip here. So go back to animation. Sorry, go to initial condition. Instead of 0, put down. Remember, the radius was 1. The area, the length of the circle, perimeter of the circle is 2 pi. R. R is 1. So the perimeter of the full circle is 6.28, 2 pi. And half of it is going to be 3. So if I put down 3.1, 3 point, I don't know, 3. If I put 3 here, it's going to take you to the other end. Now, you don't even have to look at it where it is. I'm not going to click on this to convince you it doesn't matter. If you go to a simulation, run it, wait until it finishes, select this, go to results, play animation, it starts at the other end. And if you play it, it's going to go like this. So the moral of the story is that this initial condition is a very effective way of changing the initial condition of your problem. And something that worked for roll curve, when it comes to initial condition, it does not work. So I ended up deleting that roll curve, and I manually created that in the motion design, and there was no such a thing as roll curve, because roll curve is inherited from the CATIA kinematics. Anyway, there is something called curve tangency. I use the curve tangency, and by manipulating that initial condition, I can release the cylinder at different position. Now, I will show you that if I try to do the same thing for not creating the curve tangency slash roll curve and just do it by 3D contact, how things are going to work, okay? Because there are no joints there, okay? And that would be the repeat of this tutorial or this video for video 24, which was 3D contact, not using roll curve. Okay.